how it then tells its children to reflow themselves. And then once that's done, it generally computes its height at the end, because as I mentioned earlier, the sort of the basic idea of many of these layout algorithms is that widths are input and heights are output. So one piece of information that this reflow code often uses that's in some sense more related to layout for user interface than to layout for traditionally formatted documents, although it also applies to layout for tables, is intrinsic widths. And so every piece of content essentially has two intrinsic widths. One of them is what we call the preferred width, which is basically the width it would fill if you lay out the lines of text without any line breaks. And then the second one is the minimum width, which is what you get, which is the width it would fill if you took every possible line breaking opportunity. So these two intrinsic widths tend to be used for things like table layout, and they tend to be pretty important in any user interface type of layout model. So a pretty major change between Firefox 2 and Firefox 3, one that I spent a lot of time on, was changing the way we do the calculation of these intrinsic widths so that they're calculated using a different method that's also, like reflow, a method on these frame classes. So the fourth phase of layout.
Sure. Yes, in the layout, you actually need the maximum width for step, right? I think I don't know prefer width was mainly. I think if you need a random table, so for cell, you actually need a mixing width or maximum width.
So
you need the balance.
Yeah. So some people call what I call preferred width a maximum width.
Okay.
We actually use maximum width to refer to something else that we almost never use, but it's a concept in Zool. So when you do things like table layout, often what you have is a function that has, you're taking the larger of either the minimum width or the smaller of the preferred width and the available width. So when you said preferred, so there's this third, it's.
But I guess the minimum width and the maximum width is an inner factor, and I think the outer, the container due to the width is an outer factor. I think I don't know. So maybe the preferred things that you.
So the preferred. I think this is a question of terminology, but
Okay.
but let me just.
You could probably draw on the other, not very convenient, but you could draw there. That's actually a board. Here.
Oh, on this?
Yeah.
Okay.
Yes.
So when you lay out something like a table, what you end up doing is you take the maximum of the minimum width. I hope this is large enough. And the minimum of the available width and the preferred width. So these two widths are intrinsic to the content, and this is the width that's the input width in the traditional layout. So some people call it, I don't know if that, does that answer?
I get it. The phrase maximum. And
yeah.
I mean the only container you give is available list, right?
Sorry?
The available list means all the containers you give.
Yes.
Okay.
So, on to the fourth phase of layout is where we do painting. And what we do during painting, and this is actually another major change between Firefox 2 and Firefox 3, is that we build a display list that represents all the things we need to paint. So that in this whole process, we've gone from a linear representation in the document that was sent over, turned that into a tree representation in the content tree, turned that into another tree representation in the frame tree. And then, in order to paint it, we turn it back into a linear representation that represents what we need to display. So each frame has a method where to add its appropriate display list items if they're visible in the region that we want to paint. And then we sort the display list items appropriately based on things like the order of the frames, or actually the order of the content, or based on things like the CSS z-index property, or other rules in CSS that determine what the painting order is. And then we tell each display list item to draw itself using our 2D graphics API. Now, we actually then also use this same display list code when we're handling events. So if the user clicks the mouse at a certain point, we use this display list. We build a display list not for a rectangle that we need to paint, but we build a display list for a point. And then the top item in that display list is what gets the click event, because the user clicked at that point. So I want to then finish up sort of the layout part by briefly talking about our 2D graphics API. So most systems that we run on have a 2D graphics API already. So Windows has all the basic drawing functions that we need, and Mac has all of them, and GTK has all of them. And the purpose of Mozilla having its own 2D graphics API is to hide the differences between those platform APIs. So we have our graphics API that then has an implementation on each platform, so that the layout code can deal with just a single graphics API. So all of this stuff lives in the GFX directory, which is short for graphics. But this is sort of the third, probably the biggest of the major changes in the layout engine between Firefox 2 and Firefox 3 is the changes we're making to the 2D graphics API. So our old 2D graphics API is this code that's in GFX source. But what we're doing is we're switching to using a library called Cairo that has a lot of more advanced drawing features that we want to start using. So then we have this layer called Thebes that's an API, a C++ API that wraps Cairo's API, which is in C. And then, to help with the transition between the two APIs, we have this GFX source Thebes layer, which is an implementation of the old API on top of Thebes. So that the old API used to be implemented on top of Windows graphics, and on top of Mac graphics, and on top of GTK and X11 graphics. But now we have this GFX source Thebes that implements